Universe. The universe is all of space and time, and their contents, including planets, stars, galaxies, and all other forms of matter and energy. While the spatial size of the entire universe is unknown, it is possible to measure the size of the observable universe, which is currently estimated to be 93 billion light-years in diameter. In various multiverse hypotheses, a universe is one of many, causally disconnected, constituent parts of a larger multiverse, which itself comprises all of space and time and its contents. The earliest scientific models of the universe were developed by ancient Greek and Indian philosophers and were geocentric, placing Earth at the center of the universe. Over the centuries, more precise astronomical observations led Nicholas Copernicus to develop the heliocentric model, with the Sun at the center of the solar system. In developing the law of universal gravitation, Isaac Newton built upon Copernicus's work, as well as observations by Tycho Brahe and Johannes Kepler's laws of planetary motion. Further observational improvements led to the realization that the Sun is one of hundreds of billions of stars in the Milky Way, which is one of at least hundreds of billions of galaxies in the universe. Many of the stars in our galaxy have planets. At the largest scale, galaxies are distributed evenly and uniformly in all directions, meaning the universe has neither an edge nor a center. At smaller scales, galaxies are distributed in clusters and superclusters, which form immense filaments and voids in space, creating a vast foam-like structure. Discoveries in the early 20th century have suggested that the universe had a beginning and that space has been expanding since then, and is still currently expanding at an increasing rate. The Big Bang Theory is the prevailing cosmological description of the development of the universe. Under this theory, space and time emerged together at around 13.8 billion years ago, and the energy and matter initially present have become less dense as the universe expanded. After an initial accelerated expansion called the inflationary epoch, at about 10 to the minus 32 seconds, and the separation of the four known fundamental forces, the universe gradually cooled and continued to expand, allowing the first subatomic particles and simple atoms to form. Dark matter gradually gathered, forming a foam-like structure of filaments and voids under the influence of gravity. Giant clouds of hydrogen and helium were gradually drawn to the places where dark matter was most dense, forming the first galaxies, stars, and everything else we see today. It is possible to see objects now that are further away than 13.8 billion light-years because space itself has expanded and is still expanding to this day. This means that objects which are now up to 46.5 billion light-years away can still be seen in their distant past, because in that past, when their light was emitted, they were much closer to Earth. From studying the movement of galaxies, it has been discovered that the universe contains much more matter than is accounted for by visual objects: stars, galaxies, nebulas, and interstellar gas. This unseen matter is known as dark matter. Dark means that there is a wide range of strong, indirect evidence that it exists, but we have not yet detected it directly. The Lambda-Cdm model is the most widely accepted model of our universe. It suggests that about 69.2% of the mass and energy of the universe is a cosmological constant, or, in extensions to Lambda-Cdm, other forms of dark energy, such as the scalar field, which is responsible for the current expansion of space, and about 25.8% is dark matter. Ordinary matter is therefore only 4.9% of the physical universe. Stars, planets, and visible gas clouds only form about 6% of ordinary matter, or about 0.3% of the entire universe. There are many competing hypotheses about the ultimate fate of the universe, and about what, if anything, preceded the Big Bang. While other physicists and philosophers refuse to speculate, doubting that information about prior states will ever be accessible. Some physicists have suggested various multiverse hypotheses, in which our universe might be one among many of universes that likewise exist.